In this unit, we're going to be looking at aggregate data types. The word aggregate means collection. So what we're going to look at now are ways that we can group the simpler or primitive data types into larger, more useful data types. As I mentioned before, the word aggregate means groups of data. So what we're going to look at are the four main types of aggregate data that we can use in programming languages. So the first are arrays. And arrays require that all the data that's stored in them is the same type. So in other words, we have a group of 27 integers that are a collection of data relating to one thing. So maybe we're sampling temperature over time. All of those readings would be the same data type. The second type is a specialized type of array, which is an array of characters, which are strings. And so we would use strings to represent prompts, information that the user might enter about themselves, maybe their name, their high school, their address, things like that, that are made up of characters. The third type are structures, and this allows us to group together related but different types of data. So if we were keeping track of a database, for example, information about you, your name, your address, your town of birth, your birthday, things like that. We have characters, we have numbers, we have different types of information, but they're all associated to the same chunk of information. So we would use a structure in that case. And then finally, the last type we're going to look at are unions. And unions are kind of interesting because they take one space in memory, and what it does is at various times that same space can be used for different types of data. So sometimes it could be representing an integer value, sometimes it could be a floating point number, sometimes it could be a string. It's kind of a unique little data type, and we'll talk more about that later. So let's talk about some of the reasons we might want to use arrays. One of them you've already seen, and that was your field meter, where we were taking measurements for X, Y, and Z field strength measurements, and we wanted to be able to store those to analyze them later. So that would be a perfect application for an array. The other is doing linear algebra. We want to do some matrix calculations, and one of the places that matrix calculations are very important is in graphics, so game design. So if that's something that you're interested in, you'll use arrays a lot. It's very common for us to use strings to represent data that the user would enter. So say, for example, you ask the user to enter his name or her name. That information would go in as a string and be processed as a string of characters. Now remember, a string is just an array of characters. We can get at each character independently, or we can treat the whole thing as one chunk of information. We can use strings to create simple text files. So a user types information in, we read it in as a string, we output it to a file as a string. And strings are very often used in things like coding it and decoding. So for example, you wanted to write some kind of a game program that had codes that need to be entered, or even encrypting and passwords. Those would all be strings. Structures are types of aggregate data structures that allow us to group different types of information. So say, for example, we wanted to keep track of information about a class. We could have students' names, we could have their grades, we could have their home address, we could have an email contact, all of which are different types of information. And a structure is the perfect data type to use for that. We might want to keep track of the books in a library or the books that you have on your digital device. So we would have the author, we would have the name of the book, we might have a call number. So again, different types of information that are all associated with the same thing. And we might want to keep track of a system. So we can see we have different components in this system: batteries, chargers, converters, motors, generators, each of which would have different characteristics. So this would be a place where we could have a structure that would hold information about the battery, another structure that would hold information about the converter, and so on. And those could all be grouped together into an array of structures. So even though we're getting into bigger types of structures, we can still group them together into larger structures. A perfect application for a union is inside our microprocessor, where we have accumulator A and accumulator B physically sharing the same space as D. So if we're going to emulate that in a computer program, it would make sense to use a union to do that. The union would reserve enough space for the biggest, but then we could also access A, or access B, or access D, all from that same physical space. Same thing about our condition code register. We could treat that 8-bit value as a byte, or we could treat it as various individual bits. So union would be a very good place to implement something like that. So in the videos that follow, we're going to take a look at each of these data types. First, we'll look at arrays. We'll look at the specialized arrays called strings. We'll look at structures to hold different types of data, and we'll look at unions that can hold different types but in a shared space.